Alright, let's continue where we left off. Chapter 11. We are basically trying to implement a variable. Okay. Maybe I will come back to this later on. Let's check this out. Okay. So previously we already checked out about function pointer and about pointer in general, I guess. It is quite interesting. Like this one, the select OP. It turns out this line means that we have a select OP, select underscore OP function that have a parameter OP and return a function pointer, and those function pointer need to have integer as the return value and integer for the parameter, to integer as the function parameter. In this case we have add, right, and then minus return in with what is it called, with two integer as the parameter, and add also have the same property. Okay, now the previous chapter, okay, took alpha as input and return. Wait a minute. Okay, and return alpha as output. In this chapter, our built-in function will take an extra pointer to the environment. Okay, L, A, and V as input. We can declare a new function pointer type called L built-in. Okay, what this does, as far as I understand, this is basically we are creating an alias for type alpha, for type function pointer with return value of the function that the pointer points to, alpha pointer, and with the parameter pointer AL and V and alpha pointer, something like that. In some places, why is the syntax so odd? Okay, in some places the syntax of C can look particularly weird. Okay, it can help if we understand exactly why the syntax is like this. Let us deconstruct the syntax. Okay. First, the type def can be put before any standard variable declaration. It results in the name of the variable being declared as a new type, the alias type, I guess, matching what would be the infer type of that variable. This is why in the above declaration, what looks like the function name becomes the new type name. The function name becomes the new type name, right? In this case, this one becomes the type alias, become the alias for this type. the function pointer type. Okay. Next are those asterisks. Pointer type in C are actually meant to be written with the star on the left hand. Okay, not the right hand side. Okay, something like this. This is because C-type syntax was kind of inference. Instead of reading create new in pointer x, it is meant to create a new variable x where the reference x result in an int. So from right to left, I guess, something like that. Therefore, x is inferred to be a pointer to an int. This idea is extended to function pointers too. We can read the above declaration as follows. To get an alpha pointer with the reference built in and call it with lenv pointer and alpha pointer. Therefore, built in must be a function pointer that takes an lenv pointer and returns a alpha pointer. Oh, that is mouthful to say, but yeah, something like that. Okay, cyclic types. Oh, in our implementation, I think I will try using without the type def. I will try using without the type def first and see how it goes. The L built-in type reference the alpha type and the lenv type. This means that they should be declared first in the source file. Okay. But we want to make wait a minute. But we want to make a L built-in field in our alpha struct so we can create function values. So therefore our built-in declaration must go before our alpha declaration. This leads to what is called a cyclic type dependency, where two types depend on each other. We have come across this problem before. Okay, the solution is to create a forward declaration, or what is it called? In case of function, maybe something like function prototype, I guess. Okay, but which declare a function but leave the body of it empty with types the same with types. Oh, okay. First we declare two struct types without a body. Secondly, with a type def this to the names alpha L and lenv. Then we can define our built-in function pointer type. And finally, we can define the body of our alpha struct. Now our type issues are resolved and the compiler won't complain anymore. Okay, interesting. Alpha lenv, okay, type def. next value. Okay. Struct alpha. Oh, we are using it in this one. Now this make me yeah, this make me curious though. If I'm not using type def, do I need to write this expression over and over again? I mean, the problem with that is, let's say we change the type of built-in, right? We need to change every implementation that use L built-in. Okay. LANV. Intel.h. Maybe. Function type. Can we do like this? Struct alpha LENV. Okay. Looks like we cannot do that. Looks fine, okay. Maybe I will use type def after what is the explanation here? Because we are it looks like we are using type def. the same expression, we can use multiple times. Also, if there is any problem, the same depth multiple times. But if we remove the type def, this function pointer equal a variable, which means cannot change, have multiple correlation. This is important for the placement in either file or source code files, because either file can be included in multiple source code files. Okay. And then we are replacing. Do we replace anything? Oh, the symbol. Oh no, not the symbol, but we are adding new thing. Alright. Double num. Okay. Alphabet in. Fun. Let's call it fun. Alright, we should also change this to struct. Enter. Let's see if it is compile. Okay. At least it works. Okay. Now let's see if we can use multiple lines. Okay, plus one. Wait, I'm kind of curious though. Okay, we cannot do that. C programming. Use, what is it called? Bootstrap declaration. Put the bootstrap declaration online. In one line. Okay, no. Let's see. Struct declaration. Okay. It looks like we cannot use the comma separator. Let's check variable. No. Declaration. Okay, declaration. For char p char t, tapi analyze for char p to finalize for okay. P to finalize for char function pointer void. Okay. Interesting. So we can use comma. We type def, but miscellaneous. I'm kind of curious. Variable no. Declaration keyword function struct union. Maybe by syntax we cannot do that. As with it, a new possible file type with the enumeration file. Okay, we also eating the what is it called? File type. Let's okay. Maybe I should put this at the bottom too. Oh, alpha M first. Okay. As we have added a new possible alpha type with the enumeration alpha fun. In our case, we use the alpha fun like this. We should update our relevant function that work on alphas to deal correctly with this update. In most cases, this just means inserting new cases into a switch statement. Wait, type def indicator, I guess. Is there like any convention? Oh, using underscore T. Alright, I think we can do that. Alpha. Maybe I should use this L built-in underscore T. Maybe. Not handle in switch, okay. Where is it? This one is in 493. Wait, what? If a declaration used that in interval function standard for type POSIX define time, so it is not. Oh, okay. POSIX define time. For POSIX define type. Okay. Convention, right? ST. Okay. Isn't the verb set? Okay. Confession, okay. Type and the adaptive name Toto. As an example follows with C++, which usually implicit as such. Okay. Type def. Maybe I should add T for type def, the prefix tt, and for the type def convention. Okay. Another underscore. Okay, so underscore T might be reserved for POSIX define type. So let's just use underscore TT, I guess, or ST. Oh, this is for the struct name. Okay, object name. Alright. Yeah, let's stick with TT underscore TT to indicate that this is type def. At least in my implementation. Okay. Until we don't need to do anything. Right, so in this case, the lfile delete function, right, we don't need to do anything, so Let's just do that. In doing nothing, we are doing something. Okay. For fun. Okay. New constructor, right? Let's put that in this space, I guess. Struct alpha. What is it called? Alpha fun. Let's see. Okay, I'll put in dt, right? Type def fun and fun. Okay. Okay. Alpha, right, struct alpha. Stack alpha value, malloc size of value. Okay, so we don't need to, what is it called? We don't need to change this operand, right? If we change the type value, let's say we are changing this to env, something like that, we can put this one as is, because this is evaluated at compile time. So, and we will get the type of the, what is it, the reference value, I guess. It is actually this one, or in the original case is, wait, not that one, it's this one, that the reference of value type. Okay, what? Let's do this. No, not that one. As expression. Okay, where is it? If value equal null, which means that malloc cannot assign any memory, I guess, or maybe we got some. No, that's what it means. Malloc cannot assign the memory. Either we run out of the memory or we give invalid number, I guess. But yeah, anyway, that's when malloc cannot assign the memory that we want. In this case, the size of struct alpha, how many bytes that is I'm not really sure. Oh, okay, value return value. Then we are at the end of this. Let's check. Okay, at least it is compiled. Printing a nominal string. Where is the printing? This one. Case alpha fun. Function. Then break. Don't forget to add break, because if we didn't add break in here, we will going to execute this one. It's like falling down, you know. We are also going to add a new function for copying an file. This is going to come in useful when we put things into and things out of the environment. Okay, put things into and things out of the environment. For numbers and function, we can just copy the relevant field directly. For numbers and function, we can just copy the relevant field directly. For strings, we need to copy using malloc and strcpy. Oh, copying string, yeah. Okay. Numbers and function, we can just copy the relevant field directly. I need to copy using malloc to copy list. We need to allocate the correct amount of space and then copy each element individually. I mean, the one when, what is it called? Oh, you know what? Maybe we can refactor this, but maybe, I mean, what is content again? Oh, it is in contents. What is size taken? Okay. MPC ST. Oh, is it in the And what is it? Okay. I mean, string CMP, as far as I remember, it needs to be exactly the same, right? So yeah, previously someone recommended to use, what is it called? To use this one to compare with the character, right? Rather than using string CMP, so I'm not sure about the regex one, but let's try. Okay. Yep. This one, and then removing this one. Okay. Okay, example. Okay, at least it works as expected, right? $69.42. Cannot operate unknown number. Okay, right. So we use list? No. Okay, maybe head. I kind of forgot. Head. Maybe something like this. No. Interesting. But is it also invalid before the change? Nah. Let's find out. Okay. Let me check first. Okay. Alright. Okay, it's the same. Maybe I'm just didn't understand that correctly. interesting. Oh. Yeah, I don't really understand how lips work yet. But at least we know that this is still an error. Maybe the okay, 6942. Okay. I mean, for the tuck here, right? So I use something like this. Why not? Or maybe utils. Right, okay, let's take a break and let me commit this refactor first. Not, no, no, no. Alright, git commit, okay. Refactor utils. In infrared, I guess. Comparison, okay. I didn't realize I make a typo there. Why is that? We done it to compare the string with only one character. Only one character. We can just say normal comparison with the character itself. With one character, with the first character, normal comparison with the first character, and just using normal comparison. The first character with the specified character. Here's an example. What is it called? My char equal if my char should I use complete? I mean the implementation on my string CMP will also fail. If we have null character. Okay. Don't forget to drink water. Okay, what is it? Best thing. Alpha rate, okay. Is there anything that could be? Oh, I think this one, right? Wait a minute. What is tag again? Okay. Is a pointer to char, okay? Alright. Now we are talking. Oh, I also copy the new line, okay. Plus one. Okay. And then 6942. Interesting. Let me commit that first. Yes. No. Okay. He called me a man. No edit. Okay. This kind of make me curious. 169 1. Okay. Let's see. Time to look. It would be nice if we can create some kind of test mechanism, I guess. But well, maybe next time. Wait, what? Okay. For it. Alright. Let me check if we can refactor another thing. Excuse me. I mean, yeah, I guess we can. No, let's leave it like that. With Intel. This make me curious. Do we need to copy the string? I mean, if we are using string literal, alpha copy and number directly, function and numbers directly. Okay. Where should I put that? Oh, right. Alpha fun. I kind of forgot to put this here. Alpha fun. And put entity fun. Alright, okay. Maybe at the bottom, right? Alpha pointer. Copy struct alpha value. Copy struct alpha value. Then see where is it? I don't think. Okay, maybe this one, right? Struct alpha. X. What should I name this? And why do we need this again? String. I mean, I'm kind of curious though. Let me check. C programming. I need to copy string literal. assign to them. String to character array. Okay, this is the case, right? Using array of char instead of pointer to char. Are non-assignable and non-copy initializable. Okay. Arrays in G. Historically, in value context and HS assignment, array get to pointer, okay, is what formally prevent assignment and copy initialization. This applies to all arrays, not only to char arrays. The language inherits this array behavior from its predecessor, P and PCPL language. In those languages, arrays were represented by physical pointers, and obviously reassignment of pointers is not what you want to happen when you assign one array to another. Reassignment of pointer. In C language, arrays are not pointers. They do simulate this. Okay, going to pointer in most cases. Accuracy is what keeps C arrays non-copyable to this day. String literal, you can. This is for initialization, right? In which case, conceptually, we are copying string literal to array C. Another exception is array wrapped into a struct type. It is copied when the whole struct object is copied. That's a point. Whenever you want to copy a non-wrapped array, you have to use a library. Alright, if we are using pointer to array, should we use strcpy like this one? I know for a fact, I know that what is it called? Let's say this one is error, right? That error is pointer to const char, right? Constant character. And from this one, I can just assign the memory address in pointer char const into another pointer, right? That's why I'm not really sure that we need strcpy when we use pointer char, you know. You don't have to use a library function. The library function is a better choice. System, okay. Annual pipe. I mean, is this valid? I the constant string, okay. Right, APC is not pointer string, but string literal. And the type itself does not include cons qualifier. To be even bigger. Oh, cons and constant are two very different things. Cons have been called read only. Okay, a constant or a constant expression is one that can be evaluated at compile time. Const object is one that cannot be modified at runtime. It's not char okay, but letter with which you can copy the data that there points at. I mean, let's try things out with Holy C, right? Okay, char, remove that, equal, and then print this out. Let's compare the Holy C. Okay, we can do that. Interesting. This make me curious though. Comparing the Holy C again. No, okay. Interesting. I mean, if we print out the pointer or the memory address, I guess we print out the memory address. Okay, it becomes nil. Interesting. Yeah, I mean, if we do something like this, right, 69, and we are trying to print to the reference that, we will get a segfault, as far as I understand. Holy C, okay. We are not even able to a scientist. Okay. Alright. No, not that one. Sorry about that. It should be something like this. Okay. Interesting. Oh, right. No, not this one. This one. Like dereferencing in a variable and then try to change the, what is it called? Try to change the value. Then to change the value of the integer. Okay. Holy, the holy sea. Segmentation fault. As expected. Okay, so when we are doing this, right? Can we like using this one? Like we are dereferencing pointer anu and let's and trying to put a array A, right? Let's just find out, I guess. I don't think this will work, but yep, segfault. Is the segfault because of the dereferencing? Most likely. Okay, let's try this out. Okay, holy, right. The problem is when we are trying to dereferencing. Okay. Let me compile this again. Okay. So where is it? This one is valid because we are not dereferencing P. Okay. Alright. Yeah, we are just, what is it called? Replacing the memory address stored in the pointer P. Something like that. So is one mechanism with which you can copy the data that the pointer points at APC. Okay. Isn't the only way to initialize an array detect and respect the terminating 0 at the end of the string to copy the string into S, but request to pass the length to be copied and to insert the terminating null character is present in S. Okay. Isn't an initialization but an assignment. Yeah. I mean, right. I mean, why cannot we just replace the string? No. To a modifier array. And copy the string literal into it. See, if we just modifiable char array, right? Because as far as I understand, string literal like this is read-only, so we cannot really change the first character H or the second character A in here. We need to replace this with a new string literal. And from my playground, I guess this is quite interesting. Oh, not this one. Literal. Let's say we have enu in here, and we reassign enu again to str. So if we try to run that, this one, my case, str1 having this address, right, to memory address, and str3 having the same memory address as str1, and we are using the exact same string literal enu. And surprisingly, oh, this is E2, okay, not this one. So we are also using the same thing like this one. This one is E2, ITU, the string literal, and we have the same memory address in here. It is quite interesting because I2 or E2 was set in another function called change underscore string1, like this. So it seems like the string literal persists until the end of the program. I'm still not sure what is the lifetime of string literal, and maybe we should check that out. Lifetime of string literals. Okay, wait. This one, I guess. So the lifetime of the local variable, particularly only within the function, right? I think it was called temporary lifetime, which means after foo terminate the pointer it returns no longer mean anything, right? The only value having is nothing and we are returning to our string literal. Our string literal have static storage duration. As long as of that, Yep. So that is why I'm confused, I guess. Do we need to copy the string literal like this one? As far as I understand, this line is basically we are allocating memory with malloc with the length of the string. Let's say in let's say in this line we have enu a string literal, so we have 4 character length, anu and null terminator, right? So this is what is it called? This expression means, because string length did not calculate the null terminator too, so we need to add +1, and then we copy the string from vr field to the xr field. And I've tried, right? We are trying implement that too, right? We can use something like this, basically passing the value of mesh into R. This mesh we are passing this mesh, right? This mesh into this R. And what is the value of mesh? The value of mesh is a memory address to constant char. Okay. So we are passing the memory address of the constant char, which is in my implementation is actually a string literal. So we are passing the memory address of the static value, something like that, or at least it is a value that have a static duration, static storage duration. So yeah, I'm not really sure if we need malloc in here or if we need strcpy too. If anyone know why we need to use malloc and strcpy to copy literal string, please let me know in the chat or in the comment. Maybe I'm missing something here. However, what you have a string literal which is allocated in an implementation to find read-only memory. String literal are different from local variable and they remain alive throughout the program lifetime. They have static duration. Oh, my question is that if we are using if we are using string literal, right? Do we really need to use strcpy function to copy from one string literal to another, like this one? See, copy string using malloc and strcpy. So yeah, I'm kind of confused. I mean, I've tried not using strcpy, right? Like this one, just passing the memory address from mesh to R, right? This one. So is there some difference, like maybe something more safe or safer than using this one? Oh, hello, welcome, Jasmine. I'm currently trying to learn C. Okay, hello, welcome, Muhammad. Okay, I'm trying to learn C with the help of this book, Build Your Own Lisp. Let me put this in the chat. No, I'm not really teaching anyone. The concept is that I want to learn C, and I want, what is it called? I want us to learn together, It's basically like a study group in the form of live streaming. Yeah, first we allocate the space for the line. I mean, yeah, we need to allocate the space for the length, right? But alright, thank you, Jasmine. But do we need to do this, like using strcpy to copy the literal string? I mean, like this. Can you tell me what you are going to learn from this? What's your aim for? Oh, okay, so I am trying to, what is it called? I am trying to learn about system engineering, like the low-level programming, in hope that I can do that as my full-time job. So I'm currently learning C in my preparation to try out the system engineering job, and before that I'm hoping to contribute to Linux kernel, if anyone know about the kernel janitor. This is something that I want to try, like contribute to the Linux kernel by clean up some of the code, with the to-do list and the stuff. So yeah, basically I'm trying to what is it? I'm trying to apply to job with the system engineering or low-level programming stuff. That's why I'm trying to learn C. I mean, what is it called? After learning C, I'm also trying to learn how the CPU works, how the memory works, to make me, to make me understand what's going on in the low-level programming, I guess. Programming from the ground up, if you ever heard. Let me... this one, I guess. If you ever heard about this book, after learning C, I might take a look at this book. I think this book using assembly. Let me copy this in the chat. So yeah, we might take a look at assembly too at some point. Okay. So Farun G. Are you asking if we can directly assign the string instead of doing the strcpy? Maybe maybe it's more like, do we need strcpy to copy string literal? But yeah, if put it another way, can we just like assign the string literal to another string literal, or in this case I guess pointer char, right? Or maybe is there any benefit using the, where is it, the strcpy function like this instead of, well, let me copy this. Okay, instead of just using this, oh well, I need to pick two. Is there any difference? Or maybe some consideration why using strcpy is better than assigning this directly, you know? That's what I'm still confused, I guess. I wish you all the best for your future. Thank you, Muhammad Aga. Okay, copy. Yeah, okay. Well, let's me read this first, I guess. What should we name this? Yeah, variable. Naming a variable can be hard. We already using value in here. And what is the purpose of copying again? Oh, new function for copying an alpha. This is going to come things out of the environment. Okay, and then we return x. Okay. You have to copy the data pointed by the pointer to the other pointer. I mean, then assign array. The interesting part, I already done this, See, this one is const char pointer mesh, and I just directly assign this. And for example, let's take a look at the implementation of var_r, this one. This is kind of hard to read the trigger. Where is it? Maybe this one as expression. Right. Wait, where is it? Does not start with symbol. Or maybe just the modulo one, I guess. This one, invalid modulo operation. We are using lval underscore r function, right? And in this case, we directly assign the string literal of mesh to r. Let's try this out. 1690 invalid modulo operation. So yeah, when you assign value r, call message value row r is pointing to mesh, right? And that is my confusion. Like, do we need string cpy in this case? If the string literal from this, at least from this answer, right, have the static duration. Oh, wait a minute. To modify the content of string is an undefined variable. Okay. The content of string literal, right? User programs are not allowed to modify the content of a string literal. Hence, it is always encouraged to use const while declaring OK. So this means basically we cannot just edit the S or T and so on, right? We can replace this with another memory address of the string literal. I think I also tried that in this one, the string literal playground, right? And if we run this string literal playground, okay, this one, we are actually using the same memory address for the exact same string literal, this one and this one, str3 and str1, I guess. So something like that. Yeah, that's my, basically that is my question. Like, is there any benefit to strcpy if we are talking about string literal? I mean, if it is the character of char, right? If we are to find this like this, for example, char str like this, right? then yeah, we cannot do that, I guess, because this is in the stack, as far as I understand. This is in the stack, but str is on different storage location, not in the stack. So it is not really good. Okay. I guess we will save that for later. Let's continue. This is going to come in useful when we put things into and take things out of the environment. For numbers and function, we can just copy the relevant fields directly. Oh, wait a minute. This answer, Stack Overflow answer said that it is implementation defined. But ref1. Where is the ref1? This one. Synonym literal semantic. A byte or code of value 0 is append to its multi-byte character sequence that results from a string literal to literal. Is append to its multi-byte character sequence that results from a string. The multi-byte character sequence is then used to initialize an array of static storage duration and length just sufficient to contain the sequence. Oh, okay, so it is explicitly said in the C standard. A value 0 is append to its multi-byte character sequence that results from a string literal or literal. Oh, okay. A string literal or literals. The multi-byte character sequence. See this one. It's multi-byte character sequence that result from string literal or literal. So string literal basically creating a multi-byte character sequence. At least that's what I understand, right? String literal create a multi-byte character sequence, and then those multi-byte character sequence is then used to initialize an array of static storage duration. Those multi-byte character sequence is used to initialize an array of static storage duration and length just sufficient to contain the sequence. For character string literals, the array elements have type char and are initialized with the individual bytes of the multi-byte character sequence. The string literals, the array element have type char, right? Array element have type char and are initialized with the individual bytes of the multi-byte character sequence. Array element have type char and are initialized with the individual bytes of the multi-byte character sequence. For wet string literals, what is What is wet string literal? I'm still not sure. The array element have type waiter. Okay, so there is string literal, the non-white one and the white one. Yeah, I'm still not sure. And R initialize the sequence of white character. Oh, is the white string literal means the UTF-16? Maybe. It is unspecified whether these characters are distinct, provided their elements have the appropriate value. If the program attempts to modify such an array, the behavior is undefined. Okay. So yeah, when we declare string literal, we are initialize an array of static storage duration. And what static storage duration in here means is that the duration of the storage stay until the program exits, as far as I understand. I mean, correct me if I'm wrong. Okay, and the length just sufficient to contain the sequence. Okay, interesting. So in my case, I think because I use string literal, I don't really need to use malloc, right? I mean, if I remember correctly, in this source code, the L file here, let me check. Is it in the symbolic expression here? Where is it? In this one? Oh, right. I mean, it also use pointer char. Okay. So yeah, in my case, I don't think I will use malloc and strcpy. Just directly assign the string literal. Okay, anyway, this is right. Let's take a break first. I need to go to the bathroom. Be right back. Okay, I am back. Alright, so I guess learning about string is kind of confusing, right? I mean, in a way, string is array of character. It's just the difference between string literal and non-string literal is the lifetime, I guess. I mean, wait, let me close this. When I tried out this playground, right? As we can see, the str1 having the same memory address as the str3, right? This one. And at first, I thought that, oh, maybe it will be cleaned up after we exit the function. And then I try out changing the string in another function. You know, this one, using I2, string literal. And guess what? It using the same memory address too, even after exit the function, right? It is similar to this one, right? We are using the same string literal, so I guess that's why some people say learning string in C is kind of hard, right? It's just very interesting. It is array of character, but the lifetime is different. What is it? This one, right? Let's say something like this is actually stored in the stack and have the, what is it called? Temporary duration, something like that. So when we exit the function, it will be cleaned out, as far as I understand that. So yeah, that is interesting. Another new thing we learn, right? Okay. And yeah, I haven't decided the variable name. Oh no. Let me copy this in the chat in case anyone wants to take a look. I mean, is this valid though? Okay, the type of the string literal is alright. This is because type is okay. The unknown is declared as. So if you need to take a test of it, do it as. Wow, what? This is valid? What? This is valid? Like, maybe we will try this out, you know. Let me drink some water first. But yeah, how do we check the storage duration? Like, is this considered the array of char or what? Interesting. Don't forget to drink water, everyone. Let me try this first. Let me try this first. Where is it? I mean, is it gonna cause the segfault or not? Tail. Let's use naming a variable again a. let's just use a, and then let's compile that. KCC, okay, playground, string literal playground string literal. See. Okay, what is the error in here means? Initialization of pointer char from incompatible pointer type. Compatible pointer type. Okay. So what is the lifetime, of this type? That is the important part. Okay. Or maybe there's another important thing to consider, right? It is okay. It is okay. Yeah, we can use this. We can use that now. Let me try to print that as the confusion. Let's call it confusion, right? Because I am very confused. Okay, let's try with confusion. Can we print that as a string using, what is it called, string format specifier? Let me copy this first. Okay, playground. Let's focus again. String literal playground. Oh, okay, we can. That is very confusing. I mean, let's check this out, right? PC, okay. We are initialize confusion as array of character, like literally. Literal. Yeah, what is literal in here means. Okay, background string literal. Okay, we can do that. So, maybe we should use another function to check void. What is it called again? Init array of address. To find out if we can passing this throughout what is it? The stack frame, is that how it is called? Init string. What is it? Let's just use void, right? Init string. Oh, no. Let's just call it init confusion, right? Is this the correct? Oh yeah, this is the correct type, the correct word, I guess. Okay, init confusion. What a name. Init confusion void. Okay. And we put this in here. But yeah, we need to return the value, the memory address, right? So yeah, let's change it like this. Guess maybe const char. Alright. Is it const char or not? Now let's try const char. Okay. Const char. Right, I forgot this return confusion. Returning const char. Okay. Function with incompatible return. This kind of different. I mean, how do we make this return value in the function? Is it something like this? I don't think this is. Yeah, this is not correct. Maybe something like this. No. How do we do that? Like this? We are deep into confusion, everyone. Okay. Oh, okay. Wait. I mean, from this, right? It's, I think, this is conflicting type error because of the function. What is it called? The function prototype, right? Let's try again. Okay. Yeah, I'm still not sure how we return this. Let me check the, what is it called? Let me check what the syntax mean. Okay. Where is it again? This one. Syntax error. As a pointer to array for of char. array for of char. Okay, to char. So it is considered a char like this one. Array for of char, right? Of char. Oh. Array for of char. Okay. Alright. In case anyone curious, let me paste this in the chat. Or you can check the live stream description. I put this in the description too, so okay, I'm still not able to put that in new function. So let's try the simple method, and that is this one. Can we like change this? I don't think we can, because we are taking the memory address of string literal. It is supposedly read only, right? Okay. Assignment to expression with array type. Expression with array type. Like what? Okay, let's try again. It works fine. So what this mean? Assignment expression with array type. Wait. Do we need to do this? Okay, we can compare that. Oh, wow. Alright. Oh, wait a minute. Hold on a minute. Is this another form of two-dimensional array? Like this maybe? Okay, let's print. Let's try to print the confusion, right? Okay, I'm so bad at naming scheme. And then let's string literal playground. Segmentation fault, right? I should expect that. Segmentation fault. And if we comment this, background string literal, it's looking fine, right? Oh, wait a minute. What about not using string format specifier, and instead of using the character format specifier, like this one? Background string literal. Okay. Nope, we cannot do that. This makes me curious. Should we add the warning? Oh, okay, there is a warning. this one, the confusion one. Let me hide this first. Expect argument of type int but to as type char. Oh, okay. Alright. Okay. Let's see. Alright, this. Let's just ignore this for now. Okay. Playground string literal. Okay, we got the seg fault. So what is this mean? Can we check that from GTP, right? C programming GTP check the lifetime of variable. Or maybe okay, make the scope right and right, or maybe this one, the life cycle. Function call. It is okay. We are returning the value of A, not the address of A. Aside from the fact that you have your types wrong. As we in this one, right? No, it will still be perfectly valid because the value of A, not the address of A. Oh, okay. Aside from the fact that you have your types wrong, as type and is not compatible with it's not compatible with char pointer. Interesting. If along but the address is erased, is the value stored? Okay, I mean, this is a different expression, I guess. I would love to put string literal, so I will stick to the topic at hand. However, for once, even it doesn't address your query. Okay. Integral literal. Okay. In other words, is the Following code valid. No, this code is not valid. Okay. It is involved error. Okay. See, yeah, this is another thing that's not really clear to me. Like, when is the thing L value and not L value? Take the address of a string literal, but cannot change its content. L value, the value of an expression. The value of an expression. This cannot be taken at all. Okay. Yeah, this is really confusing. Let me add this warning, right? Okay. Playground. What is it called? String literal. Okay, segfault. We are doing this. Oh, hold on a minute. Is string literal. Okay, we got a segfault. Interesting. So like, wait, let me try to print the memory address of confusion with the memory address of the string literal. Can we like do that? At least it is compiled. Okay. Alright, we have the same memory address, right? Okay, interesting. And can we like remove the address of operator, right? Like this. Yeah. In case anyone knew, this is how I learned going off on my own rather than continue reading the book. Right. I mean, I want to gain experience, so I need to try things out to gain experience. Okay, alright. This is interesting. We have 3 confusion now. It's very confusing. Right, okay. But because we are using array of, right? Can we like do this? Or will we get a segfault? Okay, we can do that, right? This one, I think it was playground string literal. Okay. Now it is different. So what does this mean? Let's try this one. Okay, there is an error. Okay, because we assign a different array size, right? Other than 4, we are assigning 5. Remember the null terminator at the end. Okay. Okay, maybe something like this to check things out, right? We are using the same memory address here. Okay, so it seems like we are in the read-only memory, I guess. In the read-only memory of the, what is it called? Of this string literal. What happens if I remove the address of operator? Okay. Char pointer 4 from incompatible pointer type. Okay. Let me add comment here. What is it called? It seems like we can print out, we can use the string literals, right? We can use the string literals memory address explicitly, yep, explicitly, like okay, but I am still not sure if we do that. Do we have the same lifetime as string literal? So lifetime like string literals, or we have the temporary lifetime. Is that what it is called? Stack lifetime. Yeah, temporary lifetime. I guess that is the term. The temporary lifetime, because it lives in the stack now. Static, what is it called? Static storage duration. Let the stack. because if we do that kind of assignment to the variable we have had the same lifetime like string literal static storage duration, or we have the temporary lifetime because it lives in the stack. In the below example, what is the lifetime of confusion variable? Is it static or storage duration? Okay, let's check that. Static duration, static or temporary? Static duration and okay. Static or temporary? What is the lifetime of confusion variable? Is it static or temporary? That is interesting. A reference. Let me copy this one. Can I like? Oh, I can. Interesting. Okay. Alright. Okay. Returning the value of A. Right. Oh. Wait. To the value, I guess, yeah. I mean the variable itself, like this confusion, right? This confusion variable, well, it should have what is it called? The temporary lifetime, because it is a variable in the function, right? So I think what my confusion is this one. Is it becoming a temporary lifetime, I guess? I'm not sure if we do that kind of assignment. The memory address. We have to the memory address to the let me to the memory address we have had the same lifetime of have had the same lifetime like string literal, or it changed. Temporary lifetime in the stack. Let me remove this and add a new one. I mean, we have different value and declaring the string literal as is, like this. Char confusion and this. What is it put? Okay. The above. The second one have type char, okay. Type, but the first one have type interesting. Syntax error, okay. As a pointer to array 4 of char. Array 4 of char. Now this make me kind of curious, like, can we do this? See, expression before curly bracket token. Wait, not this one, but this one. Initialization of char from in. Makes pointer from integer without a case. I have some idea and not sure if this is valid at all. Nope, it is not valid. Okay. Yep, this is not valid. Like, I mean, what this type represent? Yeah, I still have no idea. If anyone have a reference for explaining this one, please let me know in the chat or in the comment after the live stream. Yeah, like the title, like the variable name. This bring me confusion. Please string literal. It's literally confusing. Oh, I guess object, right? Oh, maybe the question should be like this. To address of string literal ABC have the same lifetime like string literal or change. Pointer to array for of char. To array for. What is the difference? To have different effect. Yeah, let's not talk about the lifetime first. Let's answer, I think, the question like to ampersand string literal here. What is the difference, right? If we do that, not sure what that means. What is the difference between using and saying literal directly? Literal directly. We remove this. A different type, I guess. The string literal as is. The second one have this type, right? does the difference between char and char, right? Okay. Interesting. String literal direct. System literal direct. What does the difference between maybe anyone already asked this question on the Stack Overflow between char you know what, let's point this to the no, this is fine. Okay, C programming between char and char pointer. Okay, let's see. To char, a pointer to char. A pointer to char. It allocates memory for a pointer to char. A pointer. Okay. So, does this mean that we are creating does not allocate memory for characters. It allocates memory for a pointer to char. Oh. And R holds the address of the first character. Okay. So R is not a pointer. Not char, okay, but type. Okay. No, this make me curious. Does this mean, again, it's like we have what? We have a multi-dimensional array. And well, let me try this and see if it is string literal a. What? And if we are like this, I think we will cause a seg fault, right? No. What? And why is it C? Wait. It's getting more confusing. Wait. Hold on a minute. Wait, yeah, I forgot. Let me check. What is this? Oh, where does O come from? I think this one should be an A, right? C. But this one, it is very confusing, especially for someone who new to C. Okay, so confusion with offset 0 and 0, I think. Okay, let me do this. Right, okay, let me check. String literal ABC. Like what? Why is it like this? I have no idea. Okay, if we change this, right? Oh, okay, I think, what is it called? This one is null terminator, right? I think that's the case. What should I represent null terminator again? Maybe B. Wait, what is it called? Playground string literal. Six F. Let's try this. Pointer and integer. Okay, maybe right. Playground string literal 0. Okay, so it is incorrect. It was supposed to be the null terminator, right? So what is going on? Yeah, I have no idea. Okay, let me commit this, I guess. ABC. What is the character of this one? Agitable. Oh, wait, what? Why? Why is it? Hold on a minute. Hold on a minute. Wait, it is hex, right? 6F. Oh, right. Why is it? Oh. Just a random character. That is interesting. Anyway, let me commit this first. Init confusion. Right, we should probably remove this. Right, okay. What is the difference between string literal directly? We have a different type when declaring the string literal as is. Okay. Yeah. The string literal as is and this. Okay. Second, have the type char pointer array of 4. But the first one has char playground. No, not please. Playground. Seems like sample of using trace of memory, trace of memo, a trace of string literal. New to me. Just found out about reading Stack Overflow comment, and currently I'm still not sure. What is the expression of using a trace of using string literal means? Like So I am putting this in case anyone want to see it too. And maybe they can explain that to me. So I'm putting this example in case. Interesting. And wait, what is it called? APC, right? Now this make me kind of curious again. Where is it? This one, okay. Background string literal. What? Why? Okay, that is interesting. String literal. This one. And why we have this? It looks like terminated, you know. So what is that? What is that means? Right? It's like Control R to clear. Or maybe I should use S. Background string literal. Oh. This is fascinating, I guess. Like, I mean, maybe we are like this because this expression doesn't have. Oh, wait, hold on a minute. C in this is overflow from this confusion. Is that it? That's why it is O, right? Like what? Hold on a minute. Let me change this to T, for example. Right? T. This is fascinating. String literal. See, it is still C. Why is that? No, not that one. Okay. This one, right? Okay. Oh. I guess after this I will take a break. Background string literal. Oh. Okay. This is kind of interesting. And if we do this, let's see what happens. String literal. Is this null terminator? Okay, let's check the hex value, I guess. Ground. Or maybe I should use X. Nil. Not that one. Background string literal. Nil too. Wait. Equal no. Let's see. Pointer and integer. Okay. But it is nil. Let's do this. No terminator, right? Okay. Playground string literal 1. Okay. That is actually quite interesting. So it's like a two-dimension array, right? Okay. Buffer overflow. That's it. Okay, we are starting out to see some kind of pattern. Okay. If I print it in here, right, I think we get something interesting. It is nothing, like what? background string literal. Where this come from? Is this coming from here instead? But let's try this. Okay. Oh. Okay. That is very interesting. But wait a minute. Why is it empty? Right? Why is this empty? Then, okay. Playground string literal, okay. Without. Oh, I'm disconnected for a bit. Okay. Wait. apt, right? Okay. I think this is some kind of what is it called? Array of array, I guess. Overflow confusion. Now this make me kind of curious. Right. We cannot edit the value, but we can dereference the value, right? For example, like this one. Okay. Okay. And because change string, okay. Yeah. We assign nganu, so I start with n, okay. And how about this one? Is it valid? Nope. Subscript value is neither array nor pointer nor vector, okay. So it's just itu is just array of character. Meanwhile, this one is array of array, I guess. Wait. Let me try changing this. How many characters do we have? 5, okay. 5, let's see. Yeah, I want to print out the null terminator. Yeah. String literal. Okay. How about this one? String literal s. Where does that get the s? I am not sure. But I don't want to print out the entire string. Maybe it is the file name, They start with s, string literal background, right? Okay. No terminator. Okay. I mean, this is why I'm doing live stream, to do some experiment, and maybe someone find that useful too from my experiment. String literal, okay. Terminator confusion. Okay. Alright. Not so. Okay. My hypothesis if I can type no, okay. If my hypothesis is that is similar to array of two-dimensional array, I guess. Dimensional array with column of 4. What is it called? Row, right? Row and column. Is that it? CFAQ multi-dimension array. I guess this one. Okay, row and column, right? Okay, so the row first and then the column. All right. Wait, does this mean that we can extend that confusion 1 4, something like this. CEF, because we are using T there, right? Let's find out. Nope. Nope, we cannot do that. Tar from max integer from pointer without case. Plus 1. I mean, that's basically the same thing, but let's find out. Okay. Yep, we still get the same error. I mean, if we do this, I think we won't get the error. Oh, okay, interesting. Mix integer from pointer without a case. Alright. Okay, without a case. This should be the same, right? Okay. The confusion. Char from char. So we are saving that. Oh, let me try this one. String literal, okay. Just the character. Okay. this one. Subscript value is neither array or pointer nor vector. Okay, this is interesting. Okay, we put that in the static storage space, I assume. With the column of 4, still not sure. Need more info. Okay. Jar, playground, hypothesis about trace of string literal. Trying things out. Trying things out. It looks like we we saved the character in another column. It looks like a dimensional array. The expression pt looks like a diamond. I'm still not sure, but we print out if we want to print out the character one by one, we need to dereference it twice, I guess. Need to dereference it twice like confusion. 00. With the second one using the offset. Second the reference using the offset. Zero, 1, 2. We can write that like confusion. Let's try this out. ABT. Okay. Where is it? This one. Okay. Something like this. Let me string literal. Why is it you? Wait. Okay. Background string literal. Right, why is it you? That should be the same, right? Okay. String literal. Interesting. So that's not the same thing. I'm kind of curious. Playground string segfault, right? Okay, don't have access to that. This is actually interesting. Playground string literal. You again. String literal. Wow, what? I mean, is on the second array. Second, yeah. Wait, okay. Looks like my internet connection starting to have some problem. Oh no. Let's try this out before we end that string literal. Hey, okay, so it works. Oh, wait, hold on a minute. Yeah, something like this, right? Setting, let's say 0. Okay, playground string literal. Oh, right. Okay, 0. String literal. Okay. Now we are talking. So it seems like when we are not giving the bracket, right? We maybe dereference this first using the offset first. Is that what that means? Okay, let's find out. String literal. Hey, okay. How about this one? String literal. Wait, what? Still A? Oh, right. My bad. Sometimes I need to take things slow. Right. Going too fast can be a problem. Suddenly it becomes C. So let's find out what this integer is about. String literal. Okay. Right. Segfault. Because we don't have access to that. Okay. Now if we do something like this, right, only to reference one aspect or what is it, one dimension? Is that the word? String See, this is the, what is it called? This one, right? The buffer overflow. Okay. Interesting. Let's okay. And then playground string literal. Okay. So let me add this first. Git commit amend. And the offset 1. Second difference using the offset 1. Oh, right. Let's simplify this. I guess. And we can write that like we need to put because we will try to because the square bracket, I think the square bracket is read first, right? I mean, wait, not this one. In this case, right, we use offset first and then we dereference that. You know what? For now, let's put this like that, and let's try this out. Using 0, right? To this one using 0. Okay. String. Okay. Now the problem is that using like this. Ground string. See. Maybe I should put this in here. Let's do something like this. Right. The curly bracket and see if the result is the same. Playground string. Yep, I guess it is the same. Zero and then zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12. Other than this one, let's try this one. What's going to happen? Playground string. Oh, right. It should be 0, right? Okay, this one 12. So where is the integer overflow? No, not the integer overflow, the buffer overflow going around, you know. That is kind of scary, right? But yeah, I guess this one is more appropriate to give an example. String literal. Oh, okay. Alright. Should be like this one. C to CC, okay. The expression below is the same. Produce the same result, but the thing is that it is a buffer overflow on the line print. That's why this will print C. That's why the result is C character because of character cause of confusion. I mean, so what we're having confusion of set 1, right? And then the reference does offset. Okay, if we change this to, let's say, I think 12, right? Playground string literal S. Maybe string literal. That's why when we the reference confusion with offset 1 and we get the value from ampersand character is the 12, I guess. 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then let me commit this in here. Your playground example of the reference of buffer overflow with is it called type Is that how we say it? No, accessing or accessing two-dimensional array. An example of dereferencing two-dimensional array. Example is basically this example trying to check what expression, no, not commit, what is it called, confusion, okay, and it seems like that expression is same as one. It's basically we are dereferencing the confusion memory address by offset 1 and then dereferencing the memory address again. This is the dereferencing 2, I guess, or we can also write those expression like this one, and then I think this one, right? Confusion plus 1. I mean, let's find out if that is actually correct or not. Okay. Yeah, let's put it like this, and then also change this, right? Oh no. First one. String literal. Oh, yep, it's the same. Referencing to confusion memory. Like this, okay. And then let me okay, arcade comic and no edit yep. Okay, let me check. Where is it? Okay, it is and it seems like the same as okay. By offset 1. And then dereferencing to the referencing the next memory address and then dereferencing to memory address again. Let me edit that. Wait, but the changes is correct, right? Okay, yep. Man, the next. Next memory address and then dereferencing to memory address again. Is that the correct terminology? Interesting. Not sure. If that is the explanation. Okay. The point is that the square bracket is executed first. The square bracket is executed first and then the asterisk. Bracket then the asterisk operator is executed first. I'm not sure about the terminology here. I guess that is executed first and the asterisk and then asterisk operator. The asterisk operator. Is it called operator? See plus.com tutorial, I guess. Let's see. Pointer. In some way, there is some similarity between C and C++, but yeah. Offset operator, okay. What is the asterisk? Let's call it operator. Okay. Got that first. And then the asterisk operator, okay. Alright. That is interesting. Okay, so I guess that's it for now. We will continue this on the next session. Thank you for watching and see you next time. Bye bye.